Swayam Prabha. Digital India. Educated India.
You all remember that in trying to do the mathematics of big data analytics and trying to bring the counterintuitive facts relating to volume of a sphere, volume of a cube, sphere inside a cube, cube inside a sphere, sphere inside a sphere. When we talked about creation of empty space, we had occasion to look at gamma function because the volume of a sphere is related to the gamma function, gamma k by 2, gamma k plus 1 by 2. Some of you may not have had an occasion to know about gamma distribution. Gamma distribution is a close cousin of factorial notation. Factorial is for integers, gamma is an extension of the notion of factorial. So I am going to give you a quick preview of the definition and properties of gamma functions. This is meant to make our presentation as complete as possible. Let k be 0 or any positive integer. So k is an integer either 0, so k is a non-negative integer. I am now going to define an integral I of k. The integral is defined by 0 to infinity t to the power of k e to the power of minus st dt, where s is a constant greater than or equal to 0. Those of you who have done Laplace transform, Fourier transform. So here is a function t to the power of k. You can think of this as the Laplace transform of t to the power of k. That's one way of looking at it, but I'm not going to go there. So if I set k is equal to 0, I of 0 is e to the power of minus st dt, 0 to infinity integral. I can evaluate this integral very easily. I have given you the solution. This is 1 over s. I of 1, t e to the power of minus st. I can rewrite this integral as t times d of e to the power of minus st by minus s. So this is u dv. So I am going to integrate by part. So this integral looks like integral u dv. I am going to express this as uv minus v du, integral v du. So by using integration by parts, you can evaluate. This is uv evaluated minus infinity plus infinity. This is the second integral. I am showing all the details of the integration. I am not going to, there is no point in reading this because you can readily go over that. So verify that this is equal to 1 over s square. Now let us see. When k is 0, this is 1 over s. When k is 1, this is 1 over s square. Integrating the general case for ik, integral 0 to infinity t to the power of k e to the power of minus st dt is, I am going to leave this as an assignment. In general, integrating by parts gives, so that's a very good exercise in trying to apply integration by parts theory. So, so this can be expressed as this integral. So if I iterate this, I can say ik is equal to k by s, k minus 1 by s, 2 by s, 1 by s. So factorial k divided by s to the power of k plus 1, x to the power of k plus 1. So in general, by integration by parts gives ik is equal to factorial k divided by s to the power k plus 1. I hope it is clear to all of you. So I integrated by part once, integrated by part twice. So that is an iterative integration by parts needed. I hope you recognize that. If you did that, first integration by part gives rise to the factor k by s, then k minus 1 by s, then 2 by s, 1 by s, 1 by s, this is equal to factorial k by s to the power of k plus 1. Please verify 4. That is something I would like you to do. Now, if I set s is equal to 1, what is s is equal to 1 in my integration? E to the power of minus st, s is a number which is greater than 0. So, s is a parameter I can set. So, if s is equal to 1, ik is factorial k, because the denominator becomes 1, which is equal to integral 0 to infinity to the power of k e to the power of minus t dt. Look at that, that is a beautiful result. Ik is factorial k is an integer. This integral minus infinity, I am sorry, 0 to plus infinity t to the power of k e to the power of minus t dt is equal to factorial. So, this suggests I can extend the notion of factorial from real numbers k to any number greater than minus 1. So, by convention we say ik is equal to gamma k plus 1. So, now I am introducing the notion of a gamma function. I introduced first ik, now I am going to redefine ik is equal to gamma k plus 1. So, please understand, gamma k, ik is factorial k, gamma k plus 1 is factorial k. So, in that case, gamma k is equal to t to the power 1 minus k minus 1 e to the power of t dt, k is greater than 0. You can readily see that. So, this definition 6 essentially comes from my definition of gamma. By convention, ik is equal to gamma k plus 1. Clearly, gamma k plus 1 is equal to factorial k if k greater than 0, is equal to 1 if k is equal to 0. In general, we can rewrite phi as integral 0 to infinity t to the power of k e to the power of minus st dt is equal to gamma k plus 1 divided by s to the power of k plus 1, where s is greater than 0. S is greater than 0. So, gamma k plus 1 is k times gamma k. Please understand, gamma k plus 1 is equal to factorial k. Factorial k is equal to k times factorial k minus 1, and factorial k minus 1 is k times gamma k, k times gamma k, k times gamma k. Therefore, I can rewrite this as this k by s, gamma k times gamma k divided by s to the power of k. I hope you get that. So, comparing the right hand side of 7 and 8, I get the relation gamma k plus 1 is k times gamma k, gamma 0 is 1 for any integer k. Now, this relation is called a functional relation. Why is it called a functional relation? The function gamma k is expressed in terms of itself. I don't know what it is. So, what does this functional relation tells you? This is a function is defined by itself. It's a kind of a recursive relation. It's kind of a functional relation. It's a kind of a functional relation. It's like many of you would know Fibonacci number k is equal to Fibonacci number k plus k minus 1 plus Fibonacci number k minus 2, where the initial condition f of 0 is 1, f of 1 is 1. So, it's a recurrence relation with 2 is a second order recurrence relation, which is called the Fibonacci relation. These are two initial conditions, this is a second order relation. So, a function is defined in terms of itself, that is called recursive relation. It is also sometimes called functional equation. That defines the general gamma function. Now, I would like to be able to compute gamma half. From 6, gamma half is equal to integral 0 to infinity t to the power of minus half e to the power of minus t dt. Change the variable, t is equal to u square. So, t to the power of minus half e to the power of minus 1 dt is equal to 2u du, t to the power of minus half dt 2 du. So, gamma half is equal to 2 times 0 to infinity e to the power of minus u square du. Please understand, minus e square du 0 to infinity is a close cousin of the Gaussian integral. So, I would like to be able to compute compute j, which is the integral minus infinity plus infinity e to the power minus u square du. Now, please understand, 2 times this, in other words, if I have a Gaussian distribution, the integral is minus infinity to plus infinity 1 over square root of 2 pi exponential minus x square by 2 dx. Now, please understand, x square is an even function. Therefore, minus infinity to 0 is the same as has the same value as 0 to plus infinity. So, you can express this as 1 over square root of 2 pi 2 times 0 to infinity exponential minus x squared by 2 dx. So, that's one way of looking at it. So, this is 2 times 0 to infinity e to the power minus square du. I want to be able to evaluate this integral. To do that, I am going to evaluate the integral j, which is the same integral but minus infinity plus infinity, which since e to the power of minus u square is even. Please understand, even functions. So, when do I say a function is even? If f of x is equal to f of minus x is called even function. Odd function is f of x is equal to minus of f of minus x. That is an odd function. U square is an odd function, minus u square is an odd function, e to the power of minus u square is also an odd function. It's a kind of a bell-shaped curve. So, we have already talked about computing the Gaussian integral in the module exclusively on Gaussian distribution. So, compute j, I consider j square is the product of two integrals, one u, one v. That's equal to integral minus infinity to infinity, minus infinity to infinity e to the power of minus u square plus v square du dv. I change the variables uv to r and theta. I am going from rectangular to circular coordinate. So, du is dr cosine theta, dv dr sine theta. So, du is equal to dr cosine theta minus r sine theta d theta, likewise dv. The elemental area is du dv in one coordinate, and another coordinate is dr square cosine theta sine theta minus r square cosine theta sine theta d theta square plus the other term. So, you can see d theta dr is minus dr d theta because d r du are vectors. If you multiply them, area has a sign. So, the sign of the area changes. You should be aware of that from vector algebra. The cross product A cross B is the same as minus B cross A. So, the area has an orientation. So, du dv is r dr d theta, neglecting the second order terms. So, if you multiply this, there are second order terms, first order terms. We are only keeping the first order terms because we are dealing with infinitesimals. Therefore, j square is essentially, I am able to separate the integral theta, integral r. The integral with respect to r again can be written as by integration by parts is equal to half. This is equal to 2 pi. So, j square is equal to pi. So, j is equal to square root of pi. Therefore, relating gamma half and j, since e to the power of minus u square is even, 2 times 0 to infinity e to the power of minus u square du is equal to minus infinity plus infinity e to the power of u square du. Hence 11 and 14 with 13 gives you gamma half is square root of pi. Now as a homework, we have already done this I have already given you the solution. Prove that the integral under the standard normal distribution is 1, and what is the relation between integral minus infinity plus infinity e to the power of minus x square dx and integral minus infinity plus infinity e to the power of minus x square by 2 dx. Compute their individual values. These are homework problems. These are very good exercises in integration theory that will keep you up to date in integrals evaluations. The next homework problem is compute gamma k for k is equal to 7, k is equal to 5.5, k is equal to 14. These are very good exercises in trying to evaluate the integration. You should know by now there is a error function which is related to the Gaussian distribution. The error function is defined by 2 over square root of pi 0 to x e to the power of minus u square du. So this is the Gaussian integral again. So compute the value of the error function at x is equal to 0, x is equal to 1, x is equal to 10, x is equal to 100, and x is equal to infinity. So that's a very good exercise again in integration related to gamma function. Now I have a side note. If f(t) is a real valued function, then f(s) defined by 0 to plus infinity e to the power of st f(t) is called the Laplace transform of f(t). I have already alluded to that earlier. So gamma function is defined when f(t) is t to the power of k. So you can readily see the relation, the bridge between Laplace transforms and the definition of gamma function. Even though they have same roots in terms of the definition of the integral, the applications of Laplace transform, applications of the definition of gamma function to factorial notation, computing the volumes of spheres and so on, they are different. So by setting f of k is equal to t to the power of k, comparing 16 with ik in 1 to 3, we immediately see that the close connection between Laplace transform of f of t to the power of k and the gamma function, which is an extension of the concept of factorial function. So factorial for integers, factorial for non-integers, gamma function. Gamma function is a special case of a Laplace transform. All these things are very interesting and important mathematical concepts. So when you are doing data analysis, simply don't worry about your own problem. Look at the beauty of the pathway and all the mathematical the trail that we cut and the ideas all along the trail. So that's why there is an English saying which you might all should know: the means to an end is as important as the end itself. That means enjoy the pathway, the beauty along the pathway. That's what's important. Now 2, if A is a two-dimensional vector, B is a two-dimensional vector, then B is a vector, A is a vector, angle between them is theta. A cross B is a vector whose magnitude is given by absolute value of A, absolute value of B times sine theta, and its direction is decided by the right hand rule, A to B. Hence when A is 90, the elemental area is the product of the absolute value of A and the absolute value of B, and A cross B is B cross A. We have alluded to this in our integration theory because d theta dr d theta is equal to minus d theta dr. We need to be able to understand why that is the case. That's what note 2 talks about. So note 2 talks about the sign of the elemental area. Note 1 talks about the interrelation between definition of gamma function, Laplace transform, and factorial for integers and real. So this whole appendix should be an appendix to the module that talks about mathematics of data science where we elaborated the creation of empty space, concentration measures, concentration of distances for the first time to be able to motivate the problems in high dimensional probability theory. Thank you.